In this problem, we're being asked to sketch the graph of a function that has exponentials, and we're given some information about limits and a table with some points and information about the first derivative and the second derivative. And as with all of these sketching problems we've been doing, the first derivative, of course, tells us the slope of the function at that instant, and the second derivative tells us the concavity. When you see 0 under the second derivative, that is an inflection point where the concavity changes. Where you see 0 under the first derivative, and we don't here, that's where the tangent to the function is a horizontal line where the slope is 0. So as with all of these, my suggestion would be to type in the points you have first, but let's look at this limit information so we can uh, figure out a little bit in our heads what this might look like. This says as x approaches negative infinity, the limit of the function is infinity. So it's going to be up on the left and coming in from high on the left. And then it says as x approaches infinity, the limit of the function is negative infinity. So it's going to be down on the right. So we're coming up from the upper left corner and going down to the lower right in general. Probably be some squiggling around in there too, but that's the general shape of it. So what I've done so far is I just typed in these 2 points, some strange points. I mean, -3, 0, nothing strange about that. But this point was 0, and then the y coordinate is e to the -3 halves minus e to the 3 halves. The ALEKS point graphing thing will accept complex expressions like that. And here it is. That's the y value of e to the -3 halves minus e to the 3 halves. Who knew? There it is. Once we've got that done, in this particular case, there aren't any asymptotes. There might be in an exponential, so you'd probably see some limit information that would tell you that. But in our case, we don't have any asymptotes we need to graph. So we're just going to go through each section of the graph and use these signs to tell us what our slope is and what our concavity should be. So from negative infinity up to -3, we're decreasing, so negative slope, and we're concave up. So we grab that negative slope, concave up. There we go. And that's that section of the graph. Okay. And then after, well, at this point, this is an inflection point now, so there may be some additional information. One thing that can happen is at an inflection point is it's possible you could also have a 0 for the first derivative. We don't here, so we know it's not going to be a horizontal slope there, so we keep that in mind. And after that, we go from -3 to 0, we're going decreasing in function, so negative slope and concave down. So decreasing, concave down from here to here. So it is asking us to select the behavior at the inflection point. And what we noticed, we have two choices here. Either it's a slanted tangent line or it's horizontal. We noted that the first derivative was not 0, so we're going to choose the slanted. If it was 0, you'd choose the horizontal. Okay, almost done with this one. So after 0, from 0 all the way out to infinity, it continues with a negative slope and concave down. So negative slope, concave down, and there's our thing. And as we imagined, it comes from the top left and goes down to the lower right. So this all looks good. Let's check it out and see if we got it right. And there it is. So that's a little bit of work sketching the graph of a function that has exponentials.